A robot just ran 6.5 miles per hour, not on a treadmill, not tethered to a ceiling, and most importantly, not following a pre-programmed script. This is figure 03, and it just changed the rules of humanoid movement forever. For years, we've seen humanoid robots move like they're walking on eggshells, but Figure just dropped a video showing their latest generation hitting speeds that rival a human jog entirely autonomously. And the way they achieve this is a masterclass in hardware-software synergy. To understand why this is a massive deal, we have to look past the speed. We're talking about a machine that can run for 5 hours straight while carrying a 20-kilogram payload. This isn't a science project anymore, it's a factory worker. But here's the part that's actually mind-blowing. This isn't just about faster motors. It's about a new kind of intelligence called PI 0.5 that's making decisions in real time. Let's dive into the engineering that made this possible.
Figure 03 isn't just an incremental update over Figure 02. It's a total architectural rethink. While the previous version was impressive, the 03 model introduces a level of fluidity we've never seen in a commercial humanoid. The secret sauce is the integration. Most robots are a collection of parts bought off the shelf. Figure, however, is building their own actuators and their own AI models to work in perfect harmony. It's the Apple approach, but for robotics. And the results speak for themselves. In the time it takes most research robots to take a single step, Figure 03 has already mapped its environment and adjusted its center of gravity. It's moving at the speed of thought.
Let's talk about the brain, PI 0.5. This is a vision language action model. It doesn't just see pixels, it understands the world. If you tell it to pick up the red cup, it doesn't need to be programmed for that specific cup. This model allows the robot to learn from human demonstration. Instead of writing thousands of lines of code, engineers can just show the robot how to perform a task. It's a massive shift from if-then logic to true neural learning. But the most impressive part of PI 0.5 is how it handles the unexpected. If someone bumps into the robot or moves an object mid-task, the model recalculates instantly. It's not following a path, it's solving a problem. Now, compare this to what we've seen from other companies. Many famous robot videos are highly choreographed. They're demos in the strictest sense, carefully rehearsed sequences that fail if a single variable changes. Figure is taking a different path. They are showing autonomous performance in messy, real-world environments. When Figure 03 runs, it's making thousands of micro-adjustments per second based on the friction of the floor and the air resistance. This isn't just about looking cool for the camera, it's about reliability. If a robot is going to work in a factory, it can't afford to trip because someone left a box in the wrong place. Autonomy is the prerequisite for utility.
So why does 6.5 miles per hour matter? Because in a warehouse, speed is money. If a robot moves at half the speed of a human, you need twice as many robots to get the job done. But at 6.5 miles per hour, the math starts to change. This speed puts Figure 03 in a league of its own. It's no longer a slow, lumbering machine. It's a high-performance athlete designed for the industrial world. But wait until you see what's under the hood. To reach these speeds, Figure had to abandon the old way of building robots. They had to solve the hydraulic problem. And the solution they found is genuinely brilliant.
For decades, high-power robots relied on hydraulics. Think of the massive, heavy systems used in construction. They're powerful, sure, but they're also messy, loud, and incredibly inefficient for a humanoid form factor. Figure 03 changes the game by using high-torque electric actuators. These aren't your standard electric motors. They are custom-designed powerhouses that provide the snap and strength of hydraulics with the precision of electronics. By switching to electric, Figure eliminated the need for heavy pumps and fluid reservoirs. This allowed them to cut weight significantly while increasing the robot's agility. It's like trading a sledgehammer for a scalpel. But power is nothing without control. To handle a 20-kilogram payload while running, Figure 03 needs incredible torque. We're talking about the ability to lift heavy weights while maintaining perfect balance on two legs. This is where the engineering gets really clever. The actuators are placed strategically to mimic human muscle groups. The hips and knees of Figure 03 are packed with the most powerful motors to handle the brunt of the weight. The result? A robot that can carry more than 25% of its own weight without breaking a sweat. In the world of humanoids, that power-to-weight ratio is a massive engineering win. One of the biggest enemies of electric robots is heat. When you push motors to hit 6.5 miles per hour, they get hot fast. If you don't manage that thermal energy, the robot's components will degrade or shut down entirely. Figure 03 features an advanced thermal management system that allows it to maintain peak performance for hours. This is how they achieved that staggering 5-hour runtime. It's not just a bigger battery, it's a smarter cooling system. Think about that, 5 hours of continuous operation in a factory setting. That's more than half a standard work shift on a single charge. This is the bridge between cool tech and industrial tool. Of course, skeptics point out that electric actuators have their own limits. They can't match the raw, explosive force of hydraulics in some scenarios. But for the precision needed in manufacturing, electric is the clear winner. The trade-off is worth it. Electric systems are quieter, cleaner, and easier to maintain. In a human-centric industrial environment, you don't want robots that are constantly leaking fluid or making ear-splitting noise. Figure is betting that the future of labor isn't about raw power, but about dexterous, efficient movement. And looking at the Figure 03, it's hard to argue with their logic.
But the hardware is only half the story. The PI 0.5 model is what actually tells those actuators what to do. It's a massive neural network that processes visual data and translates it into physical motion in milliseconds. This is the action part of the vision language action model. It's the bridge between seeing a box and knowing exactly how much torque to apply to the fingers to lift it. It's the most complex part of the entire system. And the most fascinating part? The more Figure 03 works, the smarter it gets. Every step and every lift is data that goes back into training the next version of the model. We're witnessing a data flywheel in motion.
Figure isn't just building these in a lab. They've already signed a deal with BMW to test these robots in their Spartanburg plant. This is the ultimate proving ground, a real factory with real deadlines and real people. In this environment, the robot isn't a toy. It has to perform repetitive tasks like moving sheet metal or organizing parts with 99% reliability. If it fails, the whole assembly line could grind to a halt. The fact that BMW is even letting Figure onto the floor is a massive vote of confidence. It shows that the technology has matured past the cool video stage and into the useful tool stage.
But with high speed comes high risk. A 300-pound robot running at 6.5 miles per hour carries a lot of kinetic energy. If it hits a person, it's not just an accident, it's a serious safety hazard. Figure has addressed this with a multi-layered safety protocol. The robot uses LiDAR and ultrasonic sensors to create a 360-degree safety bubble. If anyone enters that bubble, the robot slows down or stops instantly. This is why the PI 0.5 model is so critical. It's not just about speed, it's about awareness. The robot needs to be smart enough to know the difference between a static box and a moving human. The economic implications of this are wild. Right now, there are millions of unfilled jobs in manufacturing and warehousing. Humanoid robots like Figure 03 aren't just replacing workers, they're filling a massive labor gap. As the cost of these robots drop and their capabilities increase, we're going to see a fundamental shift in how things are made. We're moving toward a world of on-demand labor that never gets tired and never needs a break. This isn't just about efficiency, it's about resilience. A factory staffed by humanoids can operate 24/7, regardless of external conditions. It's the ultimate upgrade for the global supply chain.
So where do we go from here? Figure 03 is just the beginning. As the PI models evolve and the hardware becomes even more refined, we'll see these robots moving into even more complex environments. Imagine a robot that can help in disaster relief, or one that can assist the elderly in their homes. The same 6.5 MPH Sprint and 20-kilogram Payload that make it great for BMW also make it a versatile platform for humanity. The engineering breakthrough we're seeing today is the foundation for a new era of robotics. It's an era defined not by what robots can't do, but by how fast they can learn to do everything. Figure 03 has proven that humanoids can be fast, strong, and autonomous all at once. The 6.5 mile-per-hour sprint wasn't just a record, it was a statement. The age of the useful humanoid is finally here. And the best part? This is the slowest these robots will ever be. From here on out, the hardware gets better, the software gets smarter, and the speed only goes up. The future is moving fast, literally. The question isn't whether robots will join us in the workforce. The question is, are we ready for how quickly they're arriving? Because Figure just hit the gas, and they aren't looking back.